Okay, so hello everyone and welcome to the December annual meeting of the Kalamazoo Astronomical Society. And yes, it is technically our annual meeting, although it'll very much feel like a general meeting tonight because for the first time in probably, gosh, what, 22, 23 years, we actually have a guest speaker. Because obviously we can't do any form of holiday party. We were planning to retool our holiday party this year, do it at a restaurant this time, because frankly, after 21 years, I was very, very tired of setting up tables and chairs and stuff like that. I do not miss doing that anymore. So this is a nice reprieve from that for a year. I don't mind that at all. Although I still would prefer to be in person, but that's a whole other thing. So yeah, we do have a very special guest speaker tonight. That's probably why we have 62 people coming. So I promised we would jump right into it. So let's get with it. So tonight's guest speaker, by a fun coincidence, is our second in a row from Seattle, Washington. And she is an astronomy professor at the University of Washington, studying how the most massive stars in the universe evolve and die. She has observed for upward of 50 nights on many of the planet's largest telescopes and flown over the Antarctic stratosphere in an experimental aircraft for her research. Her academic accolades include the 2014 Annie Jump Cannon Award, a 2017 Alfred P. Sloan Fellowship, a 2019 Cottrell Scholarship Award, and the 2020 Newton Lacy Pierce Prize. She earned a bachelor's degree in physics from MIT and a PhD in astronomy from the University of Hawaii. She recently published her first popular science book called The Last Stargazers. Now, I would hold up a copy, but I've been told by my family that I am hard to shop for. So my niece was looking to get me a Christmas present, so I told her she could get me a copy of that book. So I don't have a copy just yet, but it's on my list, and I've been a good boy this year. So in The Last Stargazers, readers are taken inside the world's most powerful telescopes and introduces them to the people who run them. So without further ado, please welcome Dr. Emily Levesque.
So hi, everybody. Thank you so much for inviting me to the holiday party for the Kalamazoo Astronomical Society. I'm very happy to be a part of this. I'll be sharing my screen in just a moment and using slides to share some of the stories and kind of background that you'll find in The Last Stargazers. And I do have a copy that I can hold up and share, including sharing the beautiful cover art that my publisher helped us create, which is a drawing of the galaxy on the outside. But if you take the book jacket off, you get this beautiful starry book. So I can highly recommend a hardcover if you're looking for a special gift to get someone. And the one thing that I would ask is I'll give you the same spiel I always give my students when we are in class. Remember to mute. And then at the end of the presentation, please unmute if you have a question to ask, or if you prefer, you can put questions into the Zoom chat. It's whatever you're most comfortable with. So on the, I need permission to share my screen from whoever's hosting the party. And as soon as I have that, we'll get started. There we go. All right. So what I wanted to do was focus on my book, The Last Stargazers, and some of the stories that are told in the book, and how I sort of built this as a way to share the experience of professional astronomy with the general public. This was actually my first popular science book. I've written textbooks before, but this was my first sort of delve into the world of storytelling style writing. And as I started going to book conferences and visiting libraries and things like that, I learned that in the literary world, there's a lot of attention paid to the first line of a book. People have, memorable first lines like, call me Ishmael, or it was a dark and stormy night, and just things that they remember about how a book began. And it got me thinking, okay, well, what's the opening line of my book? It's meant to be a book exploring the world of professional astronomy and what it's like to go on adventures all over our planet to study the cosmos. So how does a book this exciting start? And my book starts with the phrase, have you tried turning it off and on again? So it's a little less sweeping than you might hope. It's a little closer to, the conversation that you have with your internet service provider, hopefully not too often. But this phrase marked one of the most startling experiences I've ever had at a telescope. So I had this said to me as a 24-year-old graduate student observing here at the Subaru telescope atop Mauna Kea Observatory in Hawaii. I had been granted a precious night of observing time that I'd had to apply for ahead of time and prepare for weeks to take some observations of distant galaxies for my PhD thesis. And I was sitting in the control room of this telescope with only one other person, the telescope operator. This telescope, just as a reminder, is an 8.2 meter telescope. So for scale, to see what a 8+ meter telescope mirror looks like, that's me standing underneath the 8.1 meter mirror of another telescope in Chile. So just to kind of get a sense of scale for what was going on. So I was sitting at this telescope in the middle of observing, and one of the computers in the control room suddenly made this horrible like thunk sound in the middle of the night. And I looked over at it, and the telescope operator looked over at it, and she said to me, "Oh no, don't worry, it's okay. I think the mirror is still on the telescope." Which wasn't a very comforting phrase. I didn't realize that a mirror could, not be on a telescope. I asked her what had happened, and she explained what she thought was going on. In this telescope, like in any large telescope, you have a setup kind of like this. So this is a good picture of Palomar Observatory working the way it's supposed to work, and Subaru is structured very similarly. The big primary mirror of the telescope is near the bottom of the screen. The secondary mirror is suspended near the top. And at Subaru, the secondary mirror was supported with the series of mechanized supports that could keep it from, tipping off of the telescope or becoming unsteady or crashing to the ground. That alarm was telling us that those supports had stopped working. At that point, the telescope was pointed straight up, but she was worried that if the alarm was telling the truth and if the supports really had ceased to function, that if we tipped the telescope too far to one side or the other, we would dump the secondary mirror off the telescope and it would go crashing to the ground. That secondary mirror weighed about 400 pounds. It was about 75 feet off the ground. If we were really lucky, it would just put a massive dent in the concrete floor. If we were unlucky, it was going to hit the 8-meter primary on the way down. So I was left to decide what to do about this. We called the engineers who run the telescope during the day, and they very cheerfully said, "Oh, it's probably just a false alarm. This is probably just a, error in the software that we noticed earlier today. You're probably fine to keep going." There was way too much probably going on in this conversation. "You can probably just ignore it, turn the telescope on and off again, like it's a modem, and go back to observing." So I was hearing this and trying to figure out what I was supposed to do, because maybe it was a false alarm. Maybe I could keep observing. Maybe I wouldn't have to lose this precious night of telescope time to an error that wasn't really there. On the other hand, if I was wrong, I knew the sorts of things that could go badly for telescopes when something mechanical failed. The infamous story, I think up until this week, of a telescope tragically collapsing was the story of the Green Bank radio telescope in West Virginia. It was working beautifully for many, many nights until one evening there was a structural failure, and that telescope went from this to this. And this was the picture in my mind while I was trying to decide if I should keep observing with Subaru, even though the mirror supports were supposedly malfunctioning. Up until this week, this was the most epic collapse ever seen at a radio telescope. I will get to what might be the new winner in a little bit. But this was the question that was posed to me as a graduate student sitting at Subaru. I was 24. I was convinced I was about to be the graduate student that killed Subaru if I made the wrong decision, or I was convinced that I was going to give up precious data for my thesis. And I sat there hearing the question, "Have you tried turning it off and on again?" going, what exactly am I supposed to do? So this story is actually how I wind up starting the last Stargazers, because it gives people this window into what it is actually like to be a scientist working at these amazing but delicate and precious facilities, trying to make decisions about how to do the research we're trying to do, and also, be good scientific citizens and keep from breaking anything too big or too expensive. These are the sorts of stories that I really wanted to share with people to try and put a human face on astronomy, because Everybody loves the sort of beauty of astronomy. Everybody loves the great Hubble photos that we tend to see on, the front page of Astronomy magazine or Sky and Telescope or on the front page of the New York Times. But very few people know the stories behind where these pictures come from. When you ask somebody to picture an astronomer, or when you Google a stock photo of an astronomer, you tend to get this. You tend to get a guy in a lab coat for some reason. He's always a guy. He's always got a beard. He's looking through a little telescope on a tripod and peering through it with his eye. And this is a very familiar stargazing experience to a lot of people, especially people who go to things like Astronomical Society open house nights. But it's not quite what we wind up doing for our jobs in the world of, large telescope astronomy. This, however, was the closest picture that I really had when I was a little kid and getting into astronomy. When I say I've been interested in astronomy since I was tiny, I really mean it. This is me at the age of 6. I am very proudly sporting my Hubble Space Telescope t-shirt because Hubble had launched earlier that year. My brother describes my face in this picture as, "What do you mean 6-year-olds can't use Hubble?" Because I was already convinced I wanted to be an astronomer and use telescopes like Hubble, but I didn't really know what that meant. I didn't know what the job of a scientist was. My best view of science as a profession came from movies. I think my main impression, thanks to Twister and Jurassic Park, was that scientists spent a lot of time being chased by their research, or that you were constantly on the verge of discovering aliens. So this was my perspective and my best window into professional science until I got to college. After my sophomore year of college at MIT, I was very lucky to have the chance to go out to Kitt Peak National Observatory in Arizona to start a research project with one of my colleagues, Phil Massey, who I actually still work with today. Phil took me up to the summit of Kitt Peak. He brought me to sort of the dining hall on our first night there, and I sat down with all these other professional astronomers, and he introduced me saying, "This is Emily, she's an astronomy student. This is her very first night observing at a professional telescope." And the whole table got so excited, and they started giving me advice saying, "Oh, remember to, start drinking caffeine at like 1 or 2 a.m. It helps you stay up late. Here's the best time to eat your night lunch," which is the extra meal that we all bring along to keep ourselves fed in the middle of the night. And then they started evolving into telling me stories, keep an eye out for scorpions. There was a woman who had a scorpion crawl up her pant leg and sting her while she was observing. Or never mind scorpions, keep an eye out for raccoons. There's a guy that had a raccoon crawl into his lap once while he was observing. And, one time I was in one of these domes here on Kitt Peak when it got struck by lightning. It was the loudest sound I'd ever heard in my life. And on and on. Did you hear about the telescope that got shot? And I remember sitting there with my fork almost stuck halfway to my mouth, just fascinated. I wanted to listen to them all night. But I also wanted to run off to a telescope and see about getting stories of my own. And years later, it kind of dawned on me what they'd really been doing at dinner that night, because these stories were a way of kind of welcoming me into the field. And the storytelling that we all do in our jobs is a way of kind of sharing with people, this is what this job is like. This is what your day-to-day experience is going to be like. These are some of the weird things that can happen. And years later, this is what wound up forming the basis of The Last Stargazers. So the book is available now. It gives people really this kind of behind the scenes storytelling driven tour through life as a professional astronomer. And it focuses on the stories and the science behind how we study the universe. The book came out in August. It just got named one of the Amazon Best Books of 2020 in their science books category. And it's also a finalist for the AAAS Subaru Prize, which is awarded for young adult science books. Now, it's written at an adult level, but it's suitable for young adult readers. So especially if you have any young people in your life who are curious about a career as a scientist and curious about space, this could be a great gift for them this holiday season. And if you want to learn more about it, you can go to thelaststargazers.com. So like I said, this was my first time writing a professional book like this, and I got to go on some wonderful adventures as part of writing the book. I think my favorite part of it, in the midst of visiting incredible observatories and getting to do things like fly on a telescope that observes out the back door of an airplane, or traveling down to Chile to visit the sites of brand new telescopes, I still think my favorite part of the research was getting to interview my colleagues and asking them questions about their own experiences. I mostly wanted to hear from I ultimately interviewed over 100 other astronomers for the book. I mostly just wanted to hear their favorite stories and their adventures of observing. So I mostly just let them talk. But there were a few questions that I asked everyone. And I wanted to highlight 3 of those questions here to just kind of guide what I wanted to talk about to all of you. The first question that I asked everyone was, what is your most memorable second or third or 10th hand observing story? And I was purposely looking for stories they had heard, that someone else had heard, that had sort of drifted into the sort of legendarium of the field, that were half true, probably sort of tall tales, but the stories that they just thought were so memorable that they kept passing them around to tell each other. I think one of the most common answers was, do you have the one about the telescope that got shot? And this is a true story. It happened at the McDonald Observatory in Texas, and it happened to the McDonald Observatory 107-inch telescope. And the story goes that one evening, one of the observatory employees, he was a telescope operator there. He was not perhaps in the most sound frame of mind, possibly was on some substances he shouldn't have been on. He got it into his mind in the middle of one night that he was going to destroy this telescope just in a fury. He stormed into the telescope building with a loaded gun, drew it on the operator, and demanded that the telescope be lowered. And fortunately, nobody was hurt. The operator lowered the telescope, and the gunman then fired 6 shots into that 107-inch mirror. I think his idea was that the mirror was just going to shatter and that would be a way to destroy it. But you all know just how thick and robust very large telescope mirrors can be. The 107-inch mirror was about this thick. It was about 1.5 feet of essentially Pyrex. So when he shot bullets into that mirror, they effectively just went thunk and stuck in the mirror like darts thrown into a dartboard. So they left these little tiny bullet holes, but basically just buried themselves and stopped. He was pretty underwhelmed. He pulled out a hammer and then started to try and go after the mirror. But at that point, he was subdued. The sheriff was called and the gunman got taken away. The sheriff then looked into the telescope to assess the damage. And he looked into the telescope and saw what you'll recognize as the Cassegrain hole, just the big hole in the primary for light to pass through to get to an instrument. He saw this giant hole and went, oh my God, the telescope's been destroyed. He had to have thought that the gunman was shooting a bazooka or something to make a hole this big. But he declared that the telescope must be, completely lost. And the rumor got out into the community that the mirror had been destroyed. In reality, the only damage was those little bullet holes. The crew was able to dig the bullets out, paint over the holes. They basically just said, well, it's not a 107-inch mirror anymore, it's a 106-inch mirror. And it went back to observing almost the very next day. The word, though, that the telescope had been destroyed got out into the broader community. And the director of the observatory had to put out an astronomer's telegram, things that are usually used to announce supernovae or variable star discoveries. He had to put out a telegram saying essentially this: don't worry, everyone, the telescope's fine. The harm suffered from the bullets was extraordinarily small, which has to be one of the more ridiculous astronomy telegrams ever posted. This has now lent my book one of its chapter titles. The harm from the bullets was extraordinarily small. And it's for sure one of the more ridiculous legendary stories that's gone through astronomy. Now, I like using this story as an example of the kind of thing that's in the book, because on the surface, it's just sort of a wacky misadventure of a story. But you have to understand a lot about astronomy to truly appreciate why this story works the way it does. You have to understand things like why the telescope is called the 107-inch. This practice of naming telescopes after their mirror diameters means you have to understand why a large mirror is so important and why it truly is the main feature that a telescope runs around. You need to understand what a telescope operator does and why a telescope operator was involved in this story. You need to know that the mirror is so thick that the bullets wouldn't shatter the glass. You need to understand what the Cassegrain hole is for to understand how silly it is that a sheriff might have mistaken it for something else. And you have to understand how precious big telescopes really are to understand how scary it might have been that we could have lost a telescope. So all of this is the scientific context that you need to understand the story. And in the book, I try to give people the context along with the storytelling and along with these sort of wacky human experiences to really help them fully appreciate some of these tales of what life is like in astronomy. So do you have the one about the telescope that got shot? It has to be the most popular story that people half recalled. The other very famous one was, what were those weird radio bursts? Something about Australia and these telescopes that detected something weird. People would sort of half remember it while telling me about it. And this was another great example of a fun astronomy story that also helps you learn a bit about astronomy along the way. This story happened at Parkes Observatory in Australia. So Parkes Observatory is a big radio telescope in Australia, and explaining even radio telescopes to people always includes the reminder of the electromagnetic spectrum, the reminder that the telescopes that we're used to using in our backyards use the visible light that we can see with our eyes, while these big radio telescopes detect much longer wavelength light that we can't necessarily see, but that still contains really valuable scientific information from space. So the Parkes Observatory in Australia, at one point in about 2007, detected this weird brief flash of radio light, and they didn't know what it was. They dubbed it a fast radio burst at first, and they said, well, that was strange. What do we think could possibly have caused that? We should try and look for more of these. And a few years later, a young postdoctoral researcher named Emily Petroff was visiting and researching in Australia and decided to try and get to the bottom of these. Now, when she asked the Parkes staff about fast radio bursts, they replied and said, oh yeah, no, that's not anything. We detect these all the time. It's probably just weird noise from something on the ground. It can't be something from space. It's probably not that interesting. Just ignore it. But Emily wouldn't quite ignore it. She knew that this could be something real. It could be a sign of some new weird phenomenon from space. And she decided to try and get to the bottom of it. She wanted to try and explain what all those other weird bursts were, to see if she could distinguish noise from things on the ground that might be emitting radio waves from a true detection from another galaxy or from far away in our own Milky Way. She wound up getting the whole observatory team in on this process, and they were testing everything around the observatory to see what could possibly produce a burst of radio waves. They named these weird radio waves perytons while they were searching. It's a mythical creature that looks like one thing but turns out to be something else. And their first clue when studying perytons is that perytons seemed to happen always around the lunchtime hour. And space is weird, but they really don't care what time lunchtime is in Australia. So that was the first hint as to what it was. So this is an aerial shot of Parkes Observatory, and you can see these sort of auxiliary support buildings around the big telescope. These hosted dorms and offices, and people would make their lunch in these buildings during the day, and they would microwave their lunch. So this was their first clue, saying maybe these perytons are coming from microwaves. And the ultimate research paper that they published on this goes into excruciating detail about like the make and model of the microwaves. Some poor person read an entire microwave manual, I'm sure, and is writing about the mechanics and like build factors of them. And they keep testing microwaves, putting in mugs of water, running the microwaves for 10 seconds or 60 seconds, and they couldn't produce a peryton. And what finally occurred to them is that they were treating the microwaves like very careful scientists. They would place a mug into the microwave, they would hit the time, they would patiently wait until it was done, and then they would look and see if there was a peryton in the data. And they decided to try acting a little more like impatient people like we all are when we're microwaving like popcorn. You don't wait for the microwave to get down to zero when it's microwaving something. You're watching it and counting it down, and you're seeing it go 3, 2, fine. And you open the door a little early, I know a lot of you have done it, to stop the microwave and get your food. Now, when they opened the door while the microwave was running, they created a peryton. They released a short little blast of radio waves that the telescope picked up and mistook for some blast from deep space. So with that solution in mind, they went back and looked through the data, and they realized that that brief burst of radio light from an impatiently opened microwave could explain all of the fast radio bursts that they had seen, except one. That burst from 2007 was not a microwave, it was real. And now the study of fast radio bursts is a whole new subfield in astronomy. We still don't really know where they come from. We know that they seem to be coming from other galaxies. We have a guess that they're coming from the dying, fast spinning cores of really massive stars, but we still are trying to suss out exactly what physically explains them. We just know now for sure that they're not microwaves. So this is another story where it gives us a nice little glimpse into how scientists work and into some of the funny mistakes we can make. And it gives people a glimpse into how radio telescopes work, which are part of astronomy that doesn't necessarily always get as much attention as optical astronomy and visible light astronomy. And I particularly wanted to highlight this story and radio astronomy this week because of this telescope. Another set of stories that I got when I asked people for their favorite remembered or their favorite second or third hand stories were stories of Arecibo Observatory in Puerto Rico. So you may recognize Arecibo. It's been in the news quite a lot this week. This is a 1,000-foot radio dish built right into a natural depression in Puerto Rico with an instrument platform suspended 500 feet above the dish. It was one of the largest radio telescopes in the world. This telescope discovered the first exoplanet, the first planet around a star besides our sun. It has managed to do things like bounce radar off distant, off other planets in our solar system and study things like the planet's surface. It's really incredible. The Arecibo telescope has been a movie star. You might recognize it from Contact, or it played, I think, the title satellite in GoldenEye. So Arecibo is a pretty iconic radio telescope, and it unfortunately had a very difficult past few months. Arecibo featured really prominently in all the radio astronomy stories that people told me. I heard about how it managed to survive Hurricane Maria and how the area under the dish, which you can see here, actually flooded, and astronomers were, riding kayaks under the dish to try and examine it and make sure it was okay. The observatory wound up serving as a aid point in the recovery during Hurricane Maria, after the fact of Hurricane Maria. Unfortunately, earlier this year, one of the auxiliary cables holding up that platform snapped, and it wound up cutting this big gash through the dish. And that's what you can see here. You can see Arecibo's dish suspended above the ground, and then the damage in the dish. There were a lot of efforts to hopefully try and save it, but this came with other structural damage. There were worries that that cable that had snapped had also damaged the instrument platform that was suspended above the dish. Just a few weeks ago, the National Science Foundation announced that they wouldn't be trying to fix Arecibo anymore, that the damage was too severe, and that they didn't want to be saddled with the expense of trying to fix it, and that they would be decommissioning the telescope. The plan was to do a controlled demolition, I'm sure, of Arecibo, but unfortunately, that platform actually collapsed earlier this week on Tuesday. So this is a picture post-collapse showing what happened to the platform. Just yesterday, it turns out the National Science Foundation actually had some video of the collapse, which you can see here. You can watch that platform in the background. You can see the cable snap, and then you can actually see the platform drop. It was a absolutely catastrophic collapse. It's amazing that nobody was hurt. What's I think especially shocking about this is that that's a video of the collapse from a security camera, but they were trying to investigate and understand exactly what had gone wrong at Arecibo. And Arecibo had a drone that was observing and trying to analyze the damage when the collapse happened. So this drone was operating, and you can see it happen as the cable starts to snap. And then as the cable finally detaches, this is an extraordinarily skilled drone pilot, just as a side note, that managed to get a shot of the actual platform as it dropped. Now, this is incredible footage. I hope that we will wind up learning a lot from this for future construction of big radio telescopes. But talking to colleagues this week, this footage has been almost hard for them to watch. Arecibo has meant such a great deal to so many people in the field. And people told me stories of their very first observing run being at this enormous radio telescope that they'd seen in the movies. There were stories about the little feral kittens that used to show up at the observatory because people fed them, and it grew into a whole, underground, cat rescue program that gave these cats homes among the astronomy community. People had stories of the community that they got to build in Puerto Rico. I have students from Puerto Rico who have talked about how Arecibo drove them to go into astronomy or go into science. And people were just absolutely heartbroken to see that this observatory, which had been working wonderfully and producing great science, was sort of left to collapse like this. This actually somewhat gets into the second question that I asked people, which was, what do you think would surprise people the most about our jobs as professional astronomers? And there's oftentimes a perception that astronomers or scientists kind of miss seeing the beauty of the natural world or the beauty of what we study because we get so fixated on the ones and zeros and the turning it off and on again and the nuts and bolts of how something works. And the way that people reacted to Arecibo was one of those surprises, I think, to a lot of people. It certainly wasn't a surprise to those of us in the field, and I doubt it'll be a surprise to any of you, but it just emphasizes how much love people have for the field, for their telescopes, for the science. People are mourning what happened to Arecibo as a real true loss. And sometimes this can get criticized. Sometimes people will say, it's just a machine. How are you mourning the loss of a machine? A machine doesn't have a soul. And I'm paraphrasing the From the Earth to the Moon TV series at this point, but a machine like Arecibo truly does have a soul. It's the soul of the people who first imagined it, who built it, who poured years of time and energy into the research that they did there, and who learned truly groundbreaking science from it. So that love of what we do and the love of the places we get to go and the incredible machines that we get to use is an indelible part of astronomy. And it was absolutely one of the things that I think a lot of my interviewees shared with me, saying, we really do this because we love it. And we do this because we find the universe to be so beautiful. And we find the places that we use in the field to be so precious. We want to make sure that everybody knows that. That was one answer. I think the other answer of what would surprise people the most is, we really don't look through eyepieces. I think I got this answer from almost everybody, because there's an understanding that everybody observes the way that people are used to observing in our backyards. And in reality, the way that astronomers tend to take data has really evolved from looking through eyepieces and taking notes through the era when we captured pictures on glass plates. So something like a photographic plate that was chemically treated, that would darken when it was exposed to light, and that you would load into the camera of a telescope and then ride along with in a setup like this. We've really evolved how we observe, from eyepieces through plates through to some of the digital technology that we now have today. I always love using this comparison of a photographic plate image of a nearby galaxy taken with really state-of-the-art plate imaging technology. So remember, this is a piece of glass that would have gotten loaded into a telescope, exposed to light. The glass would darken as the light hit it, and you would get this great little color negative image of a galaxy. It's really an exquisite picture. But when we compare this to a picture taken with something like the Subaru telescope, the telescope that I was using at the beginning of the lecture, and what we can do with modern day CCD technology and digital imaging, there's just no comparison. But this tends to surprise a lot of people who aren't already into astronomy and astrophotography, learning that we don't simply just use our eyes. The other surprise that tends to hit people are some of the really incredible adventures that we have while doing astronomy. I talked to people that traveled really to the ends of the earth in order to do astronomical research. My favorite experience, I think, in the whole book was getting to fly on board SOFIA. So this is the Stratospheric Observatory for Infrared Astronomy, pictured on the upper left. That's a modified 747 whose back door can open while in flight to reveal a telescope that's specifically designed to observe infrared light, which we can only detect from well above the water vapor in our atmosphere. The adventure of flying on that telescope and the process of learning the history of airborne astronomy, so everything from telescopes on planes to telescopes on weather balloons, like you can see on the lower left, makes up what I think is my favorite chapter of the book. I got to talk to people who travel all over the world chasing total solar eclipses to study things like the solar corona and the physics driving the solar wind. I got to talk to astronomers who had wintered over at the South Pole using the South Pole telescope, and even people who had taken part in the infamous picture of a black hole, which involved observers working at the South Pole telescope. I think my favorite story of a far-reaching telescope, though, is the telescope on the lower right. And it doesn't look that shocking at first. In fact, we see a guy in a lab coat, which I just described astronomers as not doing. But this telescope was designed by the man in the picture, George Carruthers. He was a scientist working at NASA in the 60s who invented ultraviolet detectors and basically made the field of ultraviolet astronomy possible. He built and designed this telescope to be used on the surface of the moon. It was flown to the moon on board Apollo 16. It was operated by John Young and Charlie Duke for the duration of the mission, and it took our first ultraviolet observations of nearby stars. It even got pointed back to Earth and took ultraviolet observations of the Earth itself, some of our first astronomy of our own planet. So this gives you a sense of the massive span of adventures that people wind up having in the service of doing astronomical research. So finally, the last question that I asked people was, how has astronomy changed since you've begun observing? I was talking to some people who had observed for decades. One of my close colleagues, George Wallerstein, is featured in the second chapter of the book. He has been observing for 60 years, 30 years with photographic plates, he'll tell you, and then 30 years with digital imaging. And all of these people had very interesting perspectives on how astronomy had shifted. There's the obvious shift that the technology is changing, that we go from photographic plates like this one. This is a famous photographic plate taken by Edwin Hubble when he discovered a Cepheid variable in the Andromeda galaxy and eventually discovered that Andromeda was in fact a separate galaxy. It was an amazing discovery, but it was done on this sort of older technology of a photographic plate. You can compare that to the observations of Andromeda that we now have with Hubble. This is a tiny tile of the Andromeda galaxy taken by one of my colleagues here at the University of Washington as part of a massive survey identifying individual tiny stars in Andromeda. The technological capabilities of Hubble, as opposed to that photographic plate alone, show us just how much astronomy is changing. And alongside this, the science is changing. The scientific questions that we're able to ask are evolving and getting more and more exciting. But it also changes the way that we do science and how our job as stargazers is changing. And this was the other thing that people regularly answered. They were really noticing how the stories of our job and the way we do our job have evolved with time. So the pictures on the screen right now is me standing in front of the Vera Rubin Observatory in Chile. So this is an under construction telescope named after Vera Rubin, the woman who discovered dark matter. And it's going to be coming online in, I think the plan now is October of 2022. This telescope has a really simple but really spectacular job. It's going to survey the entire southern sky over and over again every 3 nights for 10 years. So it's going to build up this just incredible, basically movie of the night sky. It's an amazing way of spotting anything that changes. We can spot an asteroid scooting through successive frames, or we can spot a variable star getting brighter and dimmer, or a supernova suddenly appearing. And we're going to have an absolute wealth of data to work with studying the changing night sky. But the telescope is also going to follow a preset pattern. There's going to be almost nobody on site. There's going to be an operator and 1 or 2 people for, basic security and safety. But the telescope is going to sort of follow that preset pattern. And this is amazing for just getting a thorough picture of the sky, but it also makes it hard with the telescope like this to chase down the occasional oddball. And sometimes the oddballs are the absolute best part of astronomy, as long as you know that they're real and not microwave ovens. Sometimes the oddballs are really the things that show us exciting new science. So my favorite example of odd science that was made possible thanks to our old way of doing astronomy, where an astronomer just sits at a telescope and gets to point it at something that they think is interesting, is this. So this is something called a Thornzhikov object, and it's one of the types of star that I study. It's an object that was predicted to exist back in the 1970s, but then wasn't seen for decades. But the idea was essentially this. Kip Thorne and Anna Zhitkov imagined a star that from the outside would look normal. From the outside, it would look like a red supergiant. It would look pretty much indistinguishable from Betelgeuse. But instead of a normal red supergiant core, a core fusing helium as fuel, this star would have a core that was essentially a neutron star. So the leftover dead core of a different star. The idea is that a red supergiant could have swallowed a neutron star and eventually had that neutron star settle to its core and produce this strange stellar structure where a star outwardly looks normal, but inside it's being supported by very exotic principles of quantum physics rather than the normal fusion we expect from stars. So Kip and Anna had predicted this star. They thought, oh, it would be so fascinating. These stars should work. Physics says they should exist. But for years, we hadn't seen any actual evidence of one. The best that we had was sort of developed ideas of how a star like this might form, because it does sound like a kind of unlikely composition for a star. So you would start with two massive stars in a binary, two blue supergiants. The more massive star would die in a supernova. You would get this amazing blast of the supernova itself, and then a neutron star left behind. Now that neutron star's companion would then puff up to become a red supergiant. The red supergiant would swallow the neutron star, and it would go from becoming a red supergiant to becoming a Thornzhikov object, but almost imperceptibly. It's so difficult to tell that there's a neutron star in there. The only real theory of how to identify one of these would be to really dig into the chemistry of the star's atmosphere. Years and years after these were predicted, Phil Massey and I, the same person I worked with on that very first research project in Kitt Peak, got the idea to go and look for these. We actually got an email from Anna Zhitkov saying, you're working on red supergiants. Have you ever thought about checking any of your stars to see if they're Thornzhikov objects? Because we were studying these stars' chemistry. We got to go to Las Campanas Observatory in Chile, which is one of my favorite places to observe and a place that I write about in the last Stargazers. We were given several nights of time to explore red supergiants in a couple nearby galaxies to see if we could spot any sign of the weird chemical signature that you would expect from a Thornzhikov object. We had applied for this time with a very carefully pre-planned list of stars. But when we got to the telescope, we revised the list at the very last minute. Almost as we were sitting down to observe, Phil turned to me and said, I have a few stars I think we should add. They're very red, they're very bright, they're good candidates. Let's just toss these on the list. Now, we were watching those stars' data come through the telescope and looking at what we got. And this is something that always disappoints reporters when they ask me about my research, because they ask me if I have beautiful pictures of my research. And I always say, oh yeah, beautiful, gorgeous pictures. Look at that. That's my data. Isn't it spectacular? They're looking at it going, it looks like channel 1. What's going on? Now, what this is the spectrum of a red supergiant. It's the light sorted out by wavelength going from the bottom to the top of the screen and from the right to the left of the screen so that we can identify little dips where atoms are absorbing light or little bright spots where atoms are emitting light. Now, when this particular thing appeared on the screen, this is completely raw, unprocessed data. One of our colleagues at the telescope, a woman named Nydia Morel, who was an expert at observing and who knew how the data from this particular telescope and instrument looked by heart. She took one look at this and said, I don't know what that is, but I know that I like it, because she had spotted these. She had spotted these little bright points in the data. Those bright points are signatures of glowing hydrogen in a star's atmosphere, which you would not expect in a normal red supergiant, but you would expect to see glowing hydrogen in the atmosphere of a Thornzhikov object. Those hydrogen atoms basically get excited by the outer layers of the star pulsing, and they will start to glow and give you a signature like this. So we had found the first observational evidence of this type of star that had been predicted 40 years earlier. And we found it because Phil was able to add a star to our list at the last minute. And because Nydia knew the telescope so well from years of observing at it that she was able to look at the data and immediately go, aha, look what we found. So it was a wonderful example of how these sort of classical old style of observing led to this sort of discovery. Now, we never could have discovered a star like this with Rubin Observatory, with the way that Rubin Observatory works. But Rubin Observatory is going to be an amazing tool to study a star like this with. With something like Rubin Observatory, we'll be able to watch how that star and how others like it get brighter and dimmer with time. It'll give us a window into the nuts and bolts of how the star works. And what we really need here is all of these different tools. We need telescopes like Las Campanas Observatory on the upper left, which let you go to a telescope and really night to night decide exactly what you want to point at. We want telescopes like the Rubin Observatory on the upper right that can take this amazing new approach to just taking almost footage of the night sky so that we can track the brightness of how these stars evolve with time. We want telescopes that have been around for decades, like the Lick Observatory that you see on the lower left. This is a historical observatory in California that is still doing exciting new research. We We want observatories like the Very Large Array and other radio telescopes like the wonderful and unfortunately no longer with us Arecibo. We're really hoping that we can rebuild Arecibo and build new and better telescopes like this so that we can keep observing the sky at all wavelengths. What we really need are all of these tools together in order to keep doing the observing that we're doing and keep asking the scientific questions that our curiosity is driving us to ask and giving us the tools we need to answer them. The last note that I always like to end on in this is kind of looking at where this leaves us for tomorrow's stargazers. And I like ending with this photo. So this is not a photo that I took with Magellan or a potential photo from Rubin or a photo taken with an enormous, beautiful telescope. I took this photo with my iPhone. I took this photo in a terribly light polluted field here in my home city of Seattle. And it's of comet Neowise, which made its close pass to Earth this past July. And I took this photo while I was getting ready for the last stargazers to come out, and while I was thinking a lot about why astronomy was important. And it's been a really interesting question to ask nowadays because of everything that's going on in the world. Taking this photo, I was standing in a field with people around me who were all standing 6 feet away and who were all wearing masks and who were all in their own little clusters and groups. We couldn't run up to each other and talk, and we couldn't, gather in little bunches like we might at a typical star party. But everyone was still there. Everyone was still in that field, standing 6 feet apart with their phones, taking these fuzzy photos of the comet. And it was a nice chance to sort of see people enjoying a shared experience. The fact that a global pandemic is currently going on has given us a really shared planetary scale experience. And it's sadly one of tragedy and really, difficult things going on and struggle for a lot of people. And this comet and getting to get a glimpse of this that was shared by lots of people in the Northern Hemisphere was a nice perspective on how astronomy can give people that kind of shared experience through joy or through triumph. When we hear something about, an exoplanet being discovered or a photograph of a black hole or a comet that we can all go see with our own eyes, it's something that we can enjoy really as planetary citizens, as science fiction as that might sound. And it's a good reminder of why astronomy matters in the way it does and why stargazing matters as much as it does. So on that note, I'll put up the information for my book again for anybody who's interested. Thank you so much again for inviting me, and I'd be happy to answer any questions that you all might have. Thanks so much. If somebody's talking, I think you are muted.
Unmute. All right. Well, thank you, Emily. I think I can unmute everyone. And of course, you'll have to unmute yourself as well, maybe. So if anyone has any questions, just speak up and ask
Emily,
away.
I have a question for you. One of the things that I've grown up in an era of Carl Sagan and Neil deGrasse Tyson, and I've watched these guys as professional scientists, professional astronomers, and then as they delve their way into more popularized versions, watching their reputations suffer. So
Yes.
Is this an issue that concerns you as an astronomer and as a scientist, that as scientists go into become more popular writers as opposed to doing the deep scientific research that everyone expects them to, that there is a backlash? Because I know Carl Sagan caught a lot of it. I know Neil deGrasse Tyson caught a lot of it. And I remember hearing a lecture from Kip Thorne several years ago where he talked about the reaction of many of his colleagues in the field because he was instrumental in helping to develop Interstellar. And he published, of course, his own book on Einstein's outrageous legacy describing black holes. Is that something that concerns you?
It's definitely, I'm glad you asked this because it's a very interesting ongoing puzzle, I think, not just in astronomy, but in any field of science where you need a really good science communicator. It was really interesting to learn more about how Carl Sagan struggled with that. I think he was on the verge of being denied tenure at Harvard because there were criticisms that he was, not serious enough as a scientist, and then Cornell went and snapped him up. It's also been very interesting to watch this and see these critiques of not being serious enough levied at the science communicators we're used to seeing, who are men. And women already have a little bit of an extra barrier to being taken seriously as scientists and as professionals. So it's an interesting risk, I think, posed by anybody trying to straddle the world of scientific research and popular writing. I think the field is getting much better about it because people are coming to recognize that if we want to keep doing astronomy and keep doing research and taxpayer-funded research, that we need to, as a critical part of our jobs, share why our research is so important with the people that support it and the people that are inspired by it. So it's been really nice to see a turn toward the positive in that area. I haven't yet had anybody accuse me of doing this, and I have a couple of research prizes I could toss back at them if they ever did. But I was really glad that I was able to do this as part of my job or alongside my day job as an astronomer, because I think it's a crucial part of what scientists do.
Thank you.
Yeah. Emily, one of my favorite telescope stories is with the horn-shaped antenna that Penzias and Wilson used, to detect the cosmic background radiation. Do you tell that story in the book about the, say, for example, the pigeon poop?
I do indeed. So if anybody already has a copy of the book or is thinking about getting one, chapter 7 of the book specifically explores radio astronomy because it's such a funky world compared to optical astronomy. I got the chance to work for a summer at the Very Large Array, and that was my introduction to radio astronomy. And I learned about all the weird quirks that they have to deal with. And one of the weird oddities that they come up against is birds pooping on the telescope. And this was one of the things that Penzias and Wilson thought might explain the cosmic microwave background. And I've loved this story of, future Nobel Prize winners kind of getting in there with a paint scraper, like, well, okay, and trying to fix the problem. And they apparently shooed the pigeons away. They trapped them and then re-released them. Apparently they were homing pigeons, so they came back. And I think they had a slightly more permanent solution eventually. Yep. But I love it as an example of the false detections that can stymie us. Another part of the book talks about gravitational wave astronomy, and they have some shockingly similar stories of the things that they can mistake for gravitational waves. And some of those are also birds. So it's a fun sort of sub-genre of astronomy, is exploring our odd detections and the weirdly prosaic things that we can mistake for astronomy.
I have a question. Have you read Dragon's Egg?
Dragon's Egg, I don't think.
It features,
I know the title, but I haven't read it. No.
Yeah, well, it sort of starts off in Southern California at JPL, and they discover a free-floating neutron star, and they go to visit it. But in the tale, say a primordial black hole is found in the center of our sun.
Mm-hmm.
So
there we go.
Right. And it's a mini. What kind of star is it that you're investigating? Right.
Thornzhikov Object. And yes, there's versions of them that would have black holes instead of neutron stars at their cores. Oh, that's great.
But also on the neutron star, this is science fiction, remember, there were these chelas. And so have you ever heard of chelas? No, because you don't have them here. Okay, so and in the end, they discovered that the sun, the chelas, because they lived at quantum computer time, so they soon surpassed us. They discovered a black hole in the sun, in our sun, and they removed it because it was going to destroy the sun. Now, suppose you have a black hole in the middle of one of your stars. How does it affect the fusion of the star?
This is a great question. And somebody asked something similar in the chat, asking, are these sorts of stars candidates for supernovae, or what would happen to them? This was a funny part of Kip Thorne and Anna Zhitkov's model, that the star would actually remain shockingly stable, that you would actually have the gravitational accretion onto the black hole or onto the neutron star. The neutron star would be a slower accretion rate and a smaller contribution, but the energy generated from that accretion could actually help to support the star. In reality, the star also has some funny effects on the fusion going on very deep in the star, so very close to the neutron star. And what we see in the star's atmosphere are predominantly the results of that chemistry. But we know that those are reactions that could basically only happen if you had a neutron star or a black hole at the star's core. So it's kind of a smoking gun for the neutron star being there. What we don't quite know is what happens when the neutron star gets massive enough to become a black hole, or if a core black hole would grow, and how exactly that would shape the way the star dies. The star could maybe just wink out. It could potentially puff itself apart, which we think is the best explanation right now. But these are even hard to computationally model. So we're still in the and nobody modeled them for a while because we had no idea they were real. So we're still in the very early phases of exploring what could happen to them.
Thank you.
Yeah.
Anybody else? Just speak up.
Well, I'll ask one more.
Okay.
I have one more.
What do you think our ninth planet is? Do you think it's a neutron star?
Oh, no,
It would have
sadly.
to be a small neutron star.
So it's really funny because one of the people that I interviewed for the book is Mike Brown, who famously is the astronomer who killed Pluto. And he's involved in research looking for what sort of the next planet would be. There's a whole interesting backstory about how Pluto got discovered, that there were theories that planetary orbits implied there must be a ninth planet. And then Pluto was found, and then it was demoted. And I spent some time researching at Lowell Observatory where Pluto was discovered, and this was a very sore point there. But in terms of what the ninth planet actually is, if there is one, I think it's hard to say exactly what it's going to be until we get a good census of sort of the Kuiper belt and the Oort cloud and the larger areas out at the edges of our solar system. But most likely it is not a neutron star, simply because that much mass concentrated that far out in the solar system would have had such a drastic orbital effect that we would have noticed.
Yeah.
I think it's hard to say exactly what it's going to be.
Thank you.
I think I've got somebody unmuted and on feedback because I'm hearing myself about
Yes,
a minute
yes.
delayed.
That's why everyone needs a set of these so they can block out all that extra noise.
Yeah.
There's another telescope, radio telescope similar to Arecibo in China, right? Like, do the US scientists get to use that one?
I don't believe that we currently have access to it. I believe that that's a national telescope in China in the same way that we have national optical or national radio observatories here. Science is an extremely international endeavor, so I'm quite sure that we have people collaborating with folks in China that have access to the telescope. I don't know that our access would change now that we don't have Arecibo. I think the much better thing would be for us to just get something like Arecibo working again. But yeah, there is now a new largest, and even before Arecibo's collapse, the Chinese telescope had surpassed it in size. So it's really good that somewhere on the planet we still have a telescope that can do these sorts of observations, and hopefully we can build more soon.
Yeah, it's called FAST, I think. FAST.
Yep. Mm-hmm.
500 meters instead of 305.
Yeah.
Any other questions? All right, so seeing none, we'll just thank you for speaking to our group. We really appreciate it. I'm looking forward to reading the book. And I hope you have a pleasant evening. You're certainly welcome to stay with us, but it was a fantastic talk. I hope everyone enjoyed it.
Thank you all so much. This was a very pleasant way to spend the evening. So have fun with the rest of the meeting.
Thank you.
All right. Thank you.
All righty. So we'll go ahead and move on here. We still have quite a few guests, but please pardon us for just a second because Normally with our general meeting, we jump right into, you know, a little bit of discussion, a little bit of this and that, but technically this is our annual meeting. So we have to finish up with final nominations and elections for 2021 KAS officers and at-large board members. So please don't bail on us. This will not take that long. We'll still have a lot of fun stuff here to come in the meeting. So I got to share my screen here. Let me bring this up. And so you should be able to see my word screen here. So of course, last month we didn't have any nominations for president. For several reasons, I've decided to go ahead and run again. I announced back in March I was not going to run. And there were kind of several reasons why. Number one, I've done it, you know, I've done a total of 15 terms. That's quite a few. Maybe back in March, and even before that, there was a little bit of burnout, but I really wouldn't call it burnout. I won't really say what it was, but it wasn't really burnout. It was something else. And of course, you know, coming into next year is a terrible time to transition into maybe somebody new, just because of our current circumstances. And now I just wanted to mention something. I'll be very vague about this, but some of you that were around back toward the end of December, January might remember, I sent out an email that said something was my fault. And I felt pretty guilty for it. And that was one of the big reasons why I wasn't going to run for president again. But I've come to learn that it wasn't my fault. So I've decided to forgive myself and move on, and figured I'll go ahead and run again. I still enjoy doing this. And frankly, you know, being president really isn't that much. If you look at the bylaws, you know, president just means you run the meetings, you run the board meetings, and you pass out awards. That's it. So pretty much everything else that you guys know that I do, that's not as president. So president is really a tiny part of what I do for the club. So I figured, oh, what the heck? Next year is a bad year to try to have somebody new. So I'll just go ahead and run again. But if anybody wants to run instead, that's also fine. So, so we have a current slate of board members. After last month's meeting, both Kevin Jung and Pete Mumbauer nominated themselves, which is totally fine. And so we do have a current slate of members at large. We have a full slate of the officers. But if anyone else wants to nominate themselves, you're certainly welcome to do so. So I'll open it up to final nominations real quick here. All right, that went really well. So I guess we're going to need a motion here to, you know, what do you say, by acclamation to accept the officers as is and forego the voting that we were supposed to do. Because if we did have to vote, it would have to be online somehow, like an online type of vote. So we need someone to make that motion.
I'll move.
All right. Anybody want to?
I second it.
All right. All in favor?
Aye.
Aye.
All right. The annual meeting's over. Woo! Now we'll just move on to the regular stuff. So let me start off with the president's report here. Lots of good news. First, I wanted to give an update with the KAS remote telescope, our facility in Arizona. As of yesterday, I confirmed the flat field routine is ready. We can now take flats with both the 20-inch plane wave and the 4-inch Takahashi. And you know, that doesn't sound terribly exciting, but what that means now is the remote telescope is 100% set up. There's no setup left to do. And when I saw that flat work last night, when I saw the flat routine work last night for the plane wave, I just felt this huge pressure off my chest, even though I'm not technically done yet. But as far as the telescope is concerned, we're done. It's ready to go. What comes next is I have to rewrite or not rewrite, but update the user manual because that needs to be updated. I mean, we're only on the first version, so there's some updates to do. And I also plan to record a training video so we don't have to do live training sessions over and over and over again. Anytime, as soon as someone pays the fee, I'll just send them the link to watch the training video, or if you just want to watch the training video, I can send you a link, and off you go, because using the remote telescope is very, very easy. And I was going to propose, if anyone wants to see a demo of the two telescopes taking flats after the meeting, we could fire up the remote telescope and give her a try. And we did have, some people join recently and pay the remote telescope fee. So I do not know exactly when I'll have the training video ready. So if you do want to take a live training session, or participate in a live training session on Zoom, of course, email me and let me know that you're interested in doing a training session. If I get at least 3, 4 people or more, that's enough to do a live training session on Zoom, because I don't, the good news is you don't have to travel anywhere. So so we can go ahead and do that. So I am so happy to have that done. Upcoming events that I'll mention now that are still a ways away. We have the 5-part Introduction to Amateur Astronomy lecture series that starts on January 23rd. Of course, like everything over the winter, that's going to be on Zoom. And we currently have 81 people registered. And I don't know how many of those will actually show up, but 81 is quite a few. And so of course we can have a total of 100 people here on Zoom. So if I hit 100, I may have to cut off registration, even though I know that all those people won't show up. But there might be a way around that. Is of course we can live stream on YouTube like we're doing right now. But I would need a volunteer to watch the YouTube channel, to watch the video on the YouTube channel, and maybe answer questions via YouTube, because I frankly won't have time to do that. So I need a volunteer to watch the YouTube channel if we even do the YouTube stream. But I also do need a volunteer to answer questions in chat on Zoom here. So, in addition to me giving the lectures, I need someone to answer chat in at least Zoom and maybe YouTube. So think about that. It doesn't have to be one person doing all 5 lectures. It could be one person doing this lecture, one person doing another lecture, and so on. Like, for example, Pete, I want you to answer questions for the Astrophoto Talk, which is the very last one. So think about that. So always looking for volunteers for something. There's no outreach, so this is something you could help. And I just want to give another shameless plug here. In addition to the 5-part lecture series, which is free, I'm doing the 12-week online Introduction to Astronomy course, a full-blown 12-week course that meets twice a week starting January 12th. I'm going to send out an email to the registrants very soon about that. If you go to the main page of the website, you'll see a slide for that, and in that running slideshow, there's a link to the syllabus on there with all kinds of information, including the fee for the course. So, of course, that is not a free thing, because it is 2 nights a week for 12 weeks. So it is a lot of work. So a little shameless plug there. And also, over the past couple of weeks, I've made significant progress in looking for speakers for next year. And I mentioned last month, I'm trying to turn a disadvantage into an advantage. So not only did we have a fantastic speaker tonight, great speaker last month, we have great speakers for the next 3 months. So for the next 3 months, we got somebody from JPL, Caltech, and then SETI. So major stuff, man, big stuff here. So you can go to the general meeting page on the website and see the current slate of guest speakers. We do have April and May speakers as well, but I'm hoping naively that we can meet in person by then. So they're kind of more local people. April is somebody from Notre Dame, and May is somebody from U of M. But if they have to, they will Zoom in. So we got some pretty heavy hitters coming up here over the next few months. And another thing, of course, another membership update. As of today, we picked up a new person today. I'm not sure if he's here, but we currently have 178 memberships. 178 paid memberships. So counting families is 2, that's well over 250 people in the Kalamazoo Astronomical Society. I think it's safe to say that we are the biggest club in the state. And we are just one away from tying the all-time record, which is 179, set back in 2017. So if you are not a member and you are joining us tonight and you thought about becoming a member, tonight's the night. Do it. Let's tie the record tonight, or maybe beat the record tonight. If we can't do it tonight, maybe we'll do it tomorrow night. And I guess I shouldn't end with bad news, but I kind of have to. It's kind of a minor thing, but we just recently discovered that this must have something to do with the American Astronomical Society buying Sky and Telescope. But the Sky and Telescope discount for club members is no more. I kind of find out when I got my renewal in the mail, because it said it was the regular $43, and I'm like, what the, and then Don confirmed it, and so if you really like that $10 Sky and Telescope discount, it is gone. But maybe, of course, the president of the AAS is at MSU. Maybe we can send her a little email and like, hey, what happened? Where's our discount? So that is the president's report. So moving on, anybody want to share any observing reports? We've had clear skies. Okay, I'll start. So last Saturday, I went out to our observatory. During the day, I pointed both telescopes at the sun. Of course, the 16-inch had the off-axis white light filter. The Teleview had the H-alpha filter, and there was these big things on the surface, like I don't know, like spots on the sun. I don't remember. They were amazing. One of them's the biggest we've had in years. So you can still see it. There's still a pretty decent sized sunspot on the sun, and I encourage everyone to check it out. It's probably past the point where you can see it with maybe your eclipse shades, but I think you could have seen it with the eclipse shades, but probably not quite anymore. But it's worth a try. So we have sunspots.
Cool.
Anybody else do any observing? At least naked eye, binoculars, telescope?
Jupiter and Saturn are getting close together.
They are.
Yeah, solstice.
I saw one of our guests here tonight. I don't know if he stuck with us. Looks like he may have left. One of our best guest speakers ever, Alan Dyer, joined us tonight. It looks like he zoomed off, and he had some great pictures that he tweeted today. So do a quick search for Alan Dyer on Twitter, and you can check him out. I was hoping maybe he could share him, but he bailed on us. See if we ever invite him again.
I see Mike Patton is on board here. I was just wondering if he could sort of say something about the remote telescope use.
Mike?
I published the usage report. It wasn't for November. It was only slightly better than October. Guys are jumping on all the early time slots. Nobody's jumped on the later time slots, trying to capture some of the images that are going to be up later in the year. But there's still a lot of open time. I'd like to see it get used more. Richard's got it complete now. So, I saw a question asked about the conjunction on the 21st. It's going to be about 11 degrees high here above the mountain. It's not going to be real high to use the big telescope. And we'd have to think through whether or not it would be pointing at the roof that slid off. But it's there to get used, guys, and don't be afraid of it.
Yeah, just people say they're intimidated. You can't break it. So give it a shot. We currently have what? God, I think 42 people that paid to use the telescope. Maybe roughly half a dozen use it on a regular basis. So, you know, again, if anyone wants to take the training session again to see how easy it is, because like I keep telling people, it's easier, a lot easier to use the remote telescope than it is the telescope in our observatory, which, you know, for visual use, the one in OWL isn't hard at all. But, you know, for astrophotography, it's a little more complicated. But the remote telescope, you're basically just pushing stuff here and there. And some people were telling me they weren't using it too much because they didn't have flats yet. But, well, you got flats. We got a pretty good dark library. We got the bias images built up. And there's a huge catalog of objects already in there that you can download and process, but you have to be a paid user to access all the images ever taken with the telescope.
And that's only $50 a year, and that's pretty darn cheap.
Yeah. So compared to
what part of the sky, which part of the sky is undershot? In other words, what I know you've got hundreds of images taken already, but there's got to be a part of the sky where there's not been much work done.
I don't.
The monsoons.
I don't look in the southeast too often, but I wanted to mention with a commercial remote telescope, you know, at least compared to a commercial remote telescope, $50 is great for one night. You know, but you can use that for pretty much the entire year, except for the monsoon season, the 3 months that were shut down. But the other 9 months, you know, basically remember one night is a way better bargain than using the remote commercial telescope for 1 year. So it's you know, we're extremely lucky to have something like this. The hard part is doing the processing.
Are you still when somebody signs up for the, you know, the access fee, are you still sending a downloaded version of the PDF that outlines the procedure? Okay.
Yep.
And just because I cannot find mine for some reason, I'm about to renew, and I just wanted to make sure I can get a copy of that.
Yeah, we got to work on that Rosette Nebula image.
Yes, I know. We it's our project. So, okay, thanks.
All right. Any other observing reports? I know it's not much. It's never been a major observing club, but we've had a remarkable amount of clear skies. I'm tongue twisted just thinking about it. It's been a very good year for clear skies. Okay, how about astronomical news?
Does imaging count?
Imaging counts. You want to share an image or two?
No, I don't need to share, but I have been out trying to collect images more in the nature of I don't know if we ever speak about EAA or electronically assisted astronomy, which is kind of a hybrid between observing and imaging. As I get older, I find that my astigmatism and, you know, I've seen all the faint fuzzies. So I like to get the camera out and see what can be done with short exposures, even using, well, especially using small portable mounts, small equipment that's easy to carry out. Sometimes we're traveling in the RV and it's, you know, I don't have the time or the energy to lug out large equipment, but I still want to look at all the beauty that's up there. And so, you know, what can be done with 30-second or up to 1 minute exposures and only in like a 5-minute integration. And it's pretty amazing what can be seen over and above the eyepiece, just the eyepiece alone. And so I've been trying to kind of gather many examples and images, thinking that maybe this club would be interested in seeing an example of that and some of the very modest equipment that can be used to achieve, you know, when, you know, you've seen enough faint fuzzies in the eyepiece and you want a little bit more, but at the same time, you don't want to, you know, get the large Dobsonian out or something of that nature. So I am interested in knowing from this club if there is interest in that, and should I put it together a presentation or anything of that nature? Would there be any interest in that?
Sounds like a good newsletter article to me.
Yeah, or even a gadget night thing for sure.
Maybe, or even a little astrophoto night feature. Yeah.
Yep.
All right. Well, I'll continue to work on that, and and get it all organized then. But I've been doing a lot of work with that lately with our clear skies.
Great. Yeah, you've got a real nice portable setup for sure.
I've been interested in observing, but the last 3 times I got my stuff together and headed out the door, I was met by 6 or more coyotes and headed back in the door really quick. So that's my story.
You need a fenced-in area to observe from.
Yeah, that's the truth. Well, it is a lot fenced in, but they don't care about the fence. That doesn't stop them.
You just gotta make yourself look big, and they won't attack you. Or is that with bears? I think that's with bears. Okay, astronomical news. Of course, I was going to talk about Arecibo, but Dr. Levesque talked about that, I think, fairly well. I was going to show the video of the collapse, but she shared that as well. One thing I saw on Twitter this week is there was a daylight meteor observable not too far from here. So did anyone see the video of that?
No, afraid not.
Well, good. I'll share it with you. Hang on.
Over by Detroit.
Yep. I don't know if anyone saw it. Here, let me, I got to find my browser. Where the HE double hockey sticks is my browser? I don't see it.
We didn't see it in Florida.
Yeah, well, I don't think it was visible quite that far away.
Sure it wasn't a White Castle?
A White Castle? Oh, here it is. Okay. I don't know what that was. Okay, let me make this full screen. If I can get on here. I'll have to make it bigger. It'll play again here. See it?
No.
I'll point it out. There it is. Look at the poles here, right here.
Oh.
Maybe with the zoom compression, it doesn't look all that great.
I don't see jack.
But it looks like it skips. There's like a bright blip here, and then it skips down like to here, then so on. So again, look at the poles there. This is in Ontario, where apparently they have snow on the ground already.
Looks like power surges to me.
Yeah, but no, that was a daylight meteor. Again, if you want to see it better, look back in our Twitter history. It's just a few days ago, so you don't have to go back very far in the history, but you can see it on there. And again, like I say in my tweet of that tweet, it's better to make the video full screen so you can actually see it. Even the guy mentioned that you lose some stuff in the Twitter compression, but you know it's there. So we had clear skies here that day, so I don't know if anyone happened to have spotted it.
I thought it was over Syracuse in New York.
It could have been visible from there, I bet.
Yeah.
But that video was in Ontario by some former cop or something like that.
Yeah, it got to the Lake Ontario, but I saw it on YouTube over Syracuse and parts of New York. It was quite visible.
Great. Trying to look through the chat here. I lost track of the chat.
Could I say something before we lose the Arecibo conversation?
Sure. Go ahead, Sam.
I'm a member of the GRAAA because I lived there, and now I live in Puerto Rico. And first of all, thanks for letting us join. You have some great programs, and I enjoy listening in when I can. But it has been, I posted this in the chat. Thank you for allowing me to do so. It's been a sad week here in Puerto Rico, and for science and astronomers, we've heard. There is a petition, if anybody is so moved. I did put in the chat the link for the petition to sign to rebuild Arecibo. Hopefully that will be done, and you know, when they rebuild, it can even be better. And it's a big loss for science and astronomy, and it'd be great to be able to replace that and move on. So It's a shameless plug for Arecibo Observatory. Thank you for letting me make it.
No problem. Yeah, I remember, gosh, how long, boy, it was nearly a decade ago, I think, when they tried to close Arecibo the first time. And of course it was saved. And then the hurricane hit it. And I think that may have done some damage that was never really fully repaired. And of course it is a humid environment too. The thing was 57 years old. So definitely would be worthwhile to build a new one. It's a great spot for it.
Yeah, there were tremors, and I'm not sure if they've concluded how much that led to the ultimate collapse this week, but there were some earthquake tremors too. So yeah, it's a great location, and if you can imagine the basics of what's there with even more up-to-date science now, it's just incredible. So.
Just need to enlist Jodie Foster to lead the fundraising campaign.
Yeah, that's right. I think a lot of people are trying to reach her.
I'd be calling Pierce Brosnan personally.
Yeah.
And Sean Bean, because he died in that too.
Yeah, that's right.
All right. Any other news? Jack?
Several things. The Chinese landed on the moon.
Yep, there's that.
Samples, and now they're just waiting for that to get around and blast off and return. Also, the Japanese that sampled the asteroid, that is supposed to return in the next few days or a week back here to Earth. So that's happening too then.
Hayabusa.
Yeah. So it's interesting, some of the non-US Russian stuff that's happening.
You didn't say it right, Richard. It's Hayabusa.
Sorry. There was also a, I haven't had a chance to look at everything yet, but I at least saw the image. There's a great, it's not really an image by Gaia. Gaia is a European spacecraft that measures distances and stuff like that. There's a great image of the Milky Way. It's not an actual picture of the Milky Way, but it's like the plots of like 1.8 billion stars with their positions and brightnesses and colors. And of course it looks like an image of the Milky Way because there are so many, but if you haven't seen that yet, go look for that. It's on like the main page of Sky and Telescope right now. So there's that. Any other news?
Richard, did you answer? I see a question here in the chat. Will we have a remote viewing session of the upcoming Saturn Jupiter conjunction around December 21?
Not remote, no. So we'll come up to that here in just a second. So with no astronomical news, let me go ahead and move on to the event horizon, and we'll kind of talk about that. So of course, after tonight, we have tomorrow. So tomorrow, the weather out west looks excellent. We have an online viewing session. So if you're not familiar with these, we basically use our remote telescope at Arizona Sky Village, which is, you guessed it, in Arizona. We are going to use our Takahashi telescope this time. For those of you that attended the first session, you know that we could not use our Takahashi. It turned out that the filter wheel just needed to be tightened down a little bit. But of course, when there's no one there, that's actually a major problem. But as soon as Mike got there, he popped it off, tightened it down, problem solved. So now the Takahashi is back in operation, so we'll be using that. And then we'll use the 20-inch play wave. So this is a great thing to do. Of course, it'll be cloudy here most likely, and if it is a little bit clear, it'll be cold. So join us from roughly 8:30 to 10:30 tomorrow night, and we'll collect at least half a dozen images with the two telescopes. And of course, as soon as the session is done, I will download the images, do a quick little processing job, and post those at the link I provided to members in the email yesterday and to those on the online viewing session email list, which is for non-members. But I will also provide the link at the end of the session tomorrow too. If you're thinking, well, I'm not on the mailing list. I'm not a member. I can't attend the session. Can I have the link? And the answer is no. No, you cannot. you got to be a member. Got to be on the mailing list.
Join.
Or you got to attend. It has to be one of those things. So join us again tomorrow, Saturday, December 5th at 8:30. It'll be a fun night. We do have a board meeting on Sunday, December 6th. Just FYI, Pete and Kevin do not have to attend that one, but you're more than welcome to come. Of course, all members are welcome to attend the board meeting Sunday at 5 o'clock. Jack, did you have something? What?
Normally we've had the board meetings on the second Sunday, and that would be the 13th. Is there a reason you bumped it to the 6th this month?
Did I screw up the date on that? I thought I had
second Sunday would be the 13th.
Let me. I have it in my calendar 13th, Richard.
I have it in my calendar also as the 13th.
Oh, maybe I goofed.
Sunday.
I've been too busy working on the remote telescope. I haven't really thought about it. So I'll look at that and I'll get back to you. It sounds like we'll do it on the 13th. But yeah, that's right. We were supposed to do it the same night as the Geminids. So I think I may have goofed up on that. I'm not sure what I was thinking. Like I said, my mind's been elsewhere lately. So it sounds like the board meeting will be on December 13th.
Thank you.
It feels like the second Sunday.
I'm worried about that great nephew coming. That's what your problem is.
Not a big deal. Next thing is we have a in-person event. In person, which means we actually get to see each other, well, at least in the dark, in the real world. We have the Geminid meteor shower on Sunday, December 13th at 7:30 p.m. But the great thing is with Richland Township Park, the gate is always open. If you want to come earlier, you can come earlier. If you want to leave or come later, you can come later. So there's no gate problem like we have at the Nature Center for stuff like this. You can come and go as you please. Just remember, try to keep your lights down a little bit. And as I mentioned in the newsletter, if the entire membership showed up, I mean, all 250 people,
plenty of room,
which ain't going to happen. As Don said, there is plenty of room for everyone to stay 6 feet apart. Richland Township Park is that big. It's huge. So don't worry about the COVID. No COVID at Richland Township Park. It's banned. Banned, I say. So, of course, what probably isn't banned are the clouds, but we'll try. So the forecast looks a little bit better right now, but who knows what it'll be 9 days from now. But it does not look like it's going to be a repeat of 1998, where it was 55 degrees, and I saw the predicted 150 meteors per hour. It was awesome. So if it is going to be clear, it's going to be cold, so get ready. But the peak this year is at like 8 o'clock our time, the perfect time for us. So if it's clear, dress warm, come out. The Geminids are worth it. Much better than the Perseids. Trust me. Better than the Perseids. Of course, I sound like Trump when I say that. Trust me. Like, okay. But I can trust. You can trust me. Trust me. If it's clear and it's going to be as good as they say they are, it's definitely worth it. And then next, we have a event roughly 800 years in the making. The Great Conjunction of Jupiter and Saturn. Those two planets will be about 6 arc minutes apart. They will fit in the field of view of the 16-inch with a 13-millimeter eyepiece, at least an ethos eyepiece anyway, which is what we have. Yeah, we cannot do this with the remote telescope. It really wasn't set up for that, and it's way too low to observe anyway. So we're going to try to do this in the real world. We can have a line spread out. People one by one can peek through the telescope in our observatory at the Nature Center, and you can see these two telescopes together in the field of view of the same eyepiece. It should be awesome. I can't wait to see it. I just really, 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 really hope it's clear. So that's the big thing, because of course these two planets, Jupiter and Saturn, you know, the last great conjunction was 2000, the year 2000, but technically they haven't been this close since like the year 1228 or something like that. So this is a pretty big deal. This is going to get a lot of media. We might get some press out at the Nature Center that night if it's clear, and I really, really hope we do, even though we can't really share it with the public.
Richard, how's the closeness, like 2 or 3 days ahead and 2 or 3 days after?
It won't be as close, but it should be pretty good. So yeah, if we do have some clear nights before or after, we can try to do that as well.
I'm just
So
date, Richard. Michigan is.
Good idea, Jack.
Time and date, Richard.
It's the Great Conjunction is Monday, December 21st. We're going to start at about 5 o'clock, but I might get there as early as 4 because we should be able to, tell the telescope, slew to Jupiter or Saturn, and we should be able to see it even before it gets, dark, because they are, at least Jupiter is pretty bright, and we should be able to observe them, even in early twilight. And but they sink fast. So if you're thinking, Richard, can I show up about maybe 7? No, show up at 5 because you have to get out there quick if you want to see this because they get low quick. We are going to need at least more than one person out there because we will have to put the walls down to see this in the southwestern sky. So we got to put the south wall down. We got to put the west wall down. Otherwise, we lose it really, really quick in the observatory. If you want to bring your own telescope, that's great. You're actually better off staying in the parking lot if you want to use your telescope. You actually get to observe it longer, I think, from the parking lot. Or if you just want to observe it by yourself, just go to Richland Township Park as well. It's a great spot to go, but we'll have it in the club telescope. Anything else? Any other comments or anything? Nope. All right, moving on. Prime Focus, always looking for articles. Hope everyone enjoyed the current issue with Eric Schroer's new observatory. I think the next issue will feature Dave Garden's observatory. I made him write an article like twice. So I really appreciate that. And I have at least 2 more articles after that. There are some people in the club I know have observatories, but never contacted me or never replied at all. So I kind of take that as no, I will not write an article for you. And so, okay, that's fine, but hurts my feelings. So hopefully everyone's enjoying the series. But if you want to submit another type of article, the deadline is the 15th of every month.
When's the last month for the last observatory? 'Cause I'm not done yet. I'm still working. Well,
if I have a gap in there, that's fine. So they don't all have to be in a row. But if I run out of articles and don't get one for a month or 2, I can always do another part. They don't have to be consecutive.
Cool. I'm taking pictures, so.
Sweet. Document. All righty. Any other things anybody wanted to mention? Everybody see my guest? Oh, Pete has one too. They're everywhere.
MC, I do.
It doesn't have. I don't have a frog though. So you can't eat a frog or an egg or anything. Grogu.
Richard, somebody mentioned in the chat about the F-117 Nighthawk fighter coming to Kalamazoo Air Zoo. That's kind of a fun thing to know about. Look forward to seeing.
Oh, I have not heard about that.
Oh, really? They are in the process of transporting right now from Nevada. They had to take the plane into 2 parts because it's 65 feet long and 45 feet wide. So they took the wings and the tail off and put it on one flatbed. And then the rest of the plane is 14 feet wide. So they've had to have special permits and travel all the way from Nevada to here with wide load and police escorts and all that kind of stuff. If you go to the Air Zoo Facebook page, they're documenting it as it's happening. And once they get it here, they have to rehab it, rebuild it, because they had to take the leading edge off of all the wings because that's all secret radar, reflecting stuff. So they had to take the leading edges off the wings and they'll have to rebuild that. The black paint had to be stripped because that's secret stuff. and the gold coating on the windshield had to be sanded off because that's special secret stuff. So once the plane gets here, they'll have to take some time to put it back together and then rehab it, refurb it, and make it look like it would normally look. So it's exciting, kind of a cool thing to know what's coming.
I did see one at the Air Force Museum, though, in Dayton, so that was pretty cool.
Well, this will be the first non-governmental museum that is allowed to have one.
Ooh. All right, that's definitely worth checking out, I think.
Ooh.
Anything else anybody wanted to mention? Anything anybody wanted to share? No? Okay, so next on the agenda is election results. So fraud, I want to recount. Oh, wait, never mind. Okay, so we'll go ahead and move on from there. Next, upcoming preview. The January general meeting will be on the 8th, because obviously we're not going to have a meeting on New Year's Day. And we have another great speaker, as I kind of alluded to earlier. It is Dr. James Ashley from the Jet Propulsion Laboratory. And he'll be speaking on the Mars InSight mission. The exact title is Gaining Insight into the Planet Mars. Of course, InSight alludes to the lander that's there right now. So that should be a very excellent talk as well. And then we got many more excellent talks, so check them out on the general meeting page. So if there's nothing else, we will go ahead and officially adjourn. Everyone just make sure you stick around to help put away the tables and chairs. Oh, wait, never mind. That's a different meeting. So
Might hang around for a couple minutes if you would.
Yeah, I'm not going to go anywhere. So if anyone wants to just hang around and chat, you're more than welcome to. But the meeting is officially adjourned. So I'm going
Jack, do you want me
to
stay here a minute